All right, ready? Hey everyone. So thank you so much for coming today. Number one, wanted to give a huge shout out to the Commit Your Code conference because this conference has been absolutely incredible. So, woo woo, that's right, yes. Appreciate y'all for coming as well today. So I just wanted to make sure, number one, that you're in the right room. We're talking about Cloud-Enabled Biometric Data Collection. Is that a new normal? If you're in the right place, wonderful. If you're in the wrong place, that's okay. There's no shame, right? Feel free to go to wherever you need, and we will continue and we will proceed. Okay, so also on a more serious note as well, before I get into this talk, I just want to make sure that I pose a small trigger warning as well. So we'll be talking today about instances of interactions with first responders, right? And how it's related more and more to normalized advancements in technology. So that could be triggering to some people and possibly a lot of folks. So I wanted to make sure that if this is triggering to you, please do whatever you have to do to protect yourself. Feel free to leave the room. You can leave the room now, no judgment, right? That's perfectly fine. But I wanted to make sure that you do what you need in order to stay safe and happy, okay? Dope. All right, love y'all. Let's get into it. So first of all, my name is Nyah Macklin. I am a senior developer advocate at this wonderful company called Neo4j. So I am a software engineer and what's called a senior developer advocate, which is the blend between software engineering and marketing. Neo4j is a graph database and analytics company that believes in the power of being connected, right? Connected to other people and connected and making relationships that you build with your community. This is one of our core tenets, actually. So when you think about graphs and graph database, you're thinking about nodes and the relationships between those nodes. So that is, like I had mentioned, a core tenet of what we do and how we operate within the world and the technology that we create as well. So sometimes it's really a privilege to be able to speak at and represent a company that that aligns to your core values. So Neo4j is that for me. So I'm very excited and very, very happy that I get to be here with y'all. So, okay, all right. So I come to tech from a non-traditional background. Are there any non-traditional engineers or tech folk in the room? Yes, I love y'all. Okay, so I actually have a degree, and that degree is in Afro and African American Studies, and that taught me not only the lived experiences of my people, but it also taught me the many ways in which those experiences are deeply rooted in our physical bodies, right? And that they show up both in tangible and intangible ways as well. And it gave me the language to articulate some of the ties between our current systems of government, right? The current developments within big tech and the inequities and injustices. Y'all didn't know we getting into it in this talk, okay? The inequities and injustices that are perpetuated and oftentimes exacerbated as well when we ignore those ties. So I was initially not interested in tech at all. Okay, I was not. I'll be honest with y'all. So how many people, when you were 5 years old, for example, when people were asking you what did you plan on being when you grew up, how many of them said, "Oh, I'm going to be a software engineer at 5"? Okay, we have one in an entire room full of people. We have one, and kudos to you for knowing, and that's incredible. But you can all see how all of our paths, they diverge and they differ so much towards where we are today. And like I had mentioned, not me. Okay, I was one of the people who did not envision myself in tech at all, and that was because, when I was a kid, I would picture, what does a software engineer look like, right? What does a software engineer look like? And sometimes you have to fight the immediate image that comes into your mind. I know I do, right? Because when you asked me this when I was young, what does a software engineer look like? They look like this, right? And this, okay? And this. Come on. So software engineers look like these three up here. I know y'all know these names, okay? So these three and people who looked like them were building the latest advancements in tech, and they were making waves, right? Investors are throwing money, right? How much money can we give to these people, right? People, when they're kids, they wanted to grow up to be just like these folk. And so we give, so should we give the genius, right? Some of them are self-proclaimed geniuses. Should we give a genius unilateral access and authority, right, over the technology that impacts our larger communities, right, every single day? So a lot of these companies are leading the charge in developing autonomous artificial intelligence. You all know about AI, right? This is huge. And when I'm specifically talking about autonomous AI, I'm talking about artificial intelligence that can perform tasks without direct human intervention or supervision. And many of us are using AI every day. So my question to you is, what are you using AI for today? Shout it out. ChatGPT. Excellent, excellent. Any other ways that you're using AI?
I'm using it for running basic PowerShell scripts to automate some of my work in Azure.
You better. Come on, automation. That's right, making your life easier. That's perfect. Go ahead. Oh my goodness. Wow. Okay, so repeating for the folk who are on the camera, this person was in a car accident a few years ago and used AI to write a story to their insurance providers in order to make sure that they understood what happened in a more clear way. Whew. Okay, I saw a hand over here as well.
Yeah, I have no shame to say it, but
yes.
I have a big family.
Yeah.
I'm sending postcards to all of them. I'm not sitting and writing.
Yes, using AI to connect with your family members. How creative is that? Okay. So this is perfect, right? AI can be used in so many creative, fun, and ways that make your life so much easier. And as we can see, right, AI can be used in email suggestions, for example, smart home devices. You say, hey, insert, insert thing here, and it'll answer to you, right? And chatbots as well. And so I want to get into a facet of how artificial intelligence is used, and really the main core of this talk, which is, what are biometrics? So does anyone know, give me an example of biometrics that you would know of. Yes?
So is the identification of individuals based on fingerprints, facial recognition, and voice pattern recognition?
Absolutely, absolutely. So biometrics, right? So biometrics, and let's break that word up as well. So bio, which is short for biology, and metrics, which is short for, it means measurement, right? So the measurement of your biology, biometrics. So it literally means measuring your biology. And so biometrics, as our friend had mentioned as well, measures the shape and placement, for example, of the ears on your face, right? The intricacies of your irises. What does that look like? A scan of your retinas in the back of your eyes, right? Aspects of your face when we're talking about facial recognition technology as well, right? The placement, the shape, and the closeness of your eyes as well, right? The shape of your nose, the shape and placement of your lips, your fingerprints, your gait, which is another word for the way you walk, okay, right? The way you walk. All of these things are frequently used in combination to identify and track who you are, right? So you might use this combination of biometrics too. For example, we have all these up here. Unlock your cell phone, right? Unlocking your cell phone, you can create fun filters, right? This poor lawyer back in the day turned themselves into a cat and had no idea how to turn it off, right? So you can put your fingerprint into your cell phone in order to open your banking app, right? You can use the privileged fast track lines at the airport as well, right? To get through security faster. You can also use iris scans, which are for some of that fast tracking that happens. But all of this is used to verify your identity when you go back to verify your identity. And then lastly, let's see, cash and checks. Has anyone ever used their fingerprint in order to cash a check before? Wow, okay, so that's fine. But we used to go to what was called the check cashing joint or the check cashing store, okay, back in the day when pre-tech, pre-tech money, okay? But you would go to the check cashing store to get your check cashed, right? And it was quite literally called the check cashing store. So great, that's what I said. That's what I said. Literally perfect branding, they knew. So the check cashing store, you would put in your fingerprint, actually, and that fingerprint, you would then put it on the check, and that would then signify that you are the person who have just cashed this check. You're not some random person. But, all right, what is cloud-enabled biometric data used for? So for me, okay, the problem is not necessarily that cloud-enabled biometric data exists at all, right? That's not my issue, okay? So the problem that I believe comes in when various artificially intelligent systems host your biometric data in the cloud, pause, and then, right, synthesize it, use it, store it, and sometimes sell that information to unknown entities, right? That begins the snowball effect of how this is going to impact various people, because you don't know how your biometric data is being used. So that's when the problems with biometric data to identify an individual, already in itself, we understand that process is not foolproof, right? And when we take that data and we possibly sell it to others to make judgments, right, for or against me as the individual, we might come into some issues. And so facial recognition technology is just one example of an artificial intelligent biometric system that can be used to create, yes, fun filters, right, and unlock your phone very fast, but it can also be used to harm communities, even when that harm is not 100% purposeful. So yet again, I'm going to do the trigger warning, but let me just, before I even get into that, let me explain to y'all, just in general, how does facial recognition work? So in facial recognition, right, the software, so we have a software, and it's going to create a map of your facial features, right? So it's going to create a map of your facial features, either from a photograph. If you've gone through the airport, they ask you, hey, stand in front of this camera. They snap the picture. They don't even tell you that you can opt out. I do every time. So please, I also encourage you to protect your data and opt out. However, so it's going to take a facial map of your facial features and then create something what is called a facial signature, right? So a signature involves what I had mentioned before, the precise location of the eyes on your face, right? Any scars that you might have on your face as well. The placement of your cheekbones, right? The shape of your nose, the features of your face that tell you apart from the next person. And this information is then stored in the cloud, which again, as we already know, the cloud is, right, someone else's computer, okay? So most simply, right? So then that information is then compared with a database of known faces in order to find a match. Okay, so your facial signature is unique, right? Supposedly. So there should never be any mistakes when it comes to recognizing who you are. Makes sense. Computers never make mistakes, right? Exactly. Yes, the chuckles tell me y'all know. That's ridiculous. That's utterly ridiculous. And so here's some of the research that was done. This is an older piece of research, but I just wanted to make sure that you are all aware facial recognition is not perfect, right? So pictured here are two absolutely incredible AI researchers. If you don't know them, you should already know them, or you should take a picture of this so that you can find this particular paper. But picture here is Joy Buolamwini, who is a prominent computer scientist who at the time of writing this paper was a researcher at MIT and who has now founded the Algorithmic Justice League alongside their colleague Timnit Gebru, right, who's the executive director of the Distributed Artificial Intelligence Research Institute, or DARE, okay? And they both together co-authored a groundbreaking paper at the time. I think this was back in 2018. Yes, 2018. So back in 2018, called Gender Shades, Intersectional Accuracy Disparities, right, in Commercial Gender Classification. And this paper demonstrated that machine learning algorithms can in fact discriminate based on classes like race and gender. And again, this was back in 2018, right, that development was happening. A lot of us started using ChatGPT in 2020-ish, a little bit later, 2021. But this work, it goes back decades, right? So it's not just as new as we might think. And I want to go through the findings of that paper as well. So that paper, which used a pilot parliament's benchmark data set, and so that data set, this data set, it includes parliament members, right? So well-known people, this isn't just random people, but this data set included well-known parliament members, and used their faces in order to track whether it could understand whether this was what gender that person was or what race that person was. So this data set took prominent public figures in various countries around the world and used their faces to test whether 3 different well-known and highly used, okay, remember that, highly used commercial classifier systems would recognize their demographic and phenotypic traits. Y'all already know where this is going, okay? We know that bias exists within these systems, and let's get into a little bit of the data as well. So the findings here, this might look like a bunch of data to you, but let me synthesize a little bit of these findings. So the findings show gender classification performance as measured by true positive rate. We'll see true positive rate, TPP, TPR, right? True positive rate that measured the percentage of the actual positives that are accurately identified, or the error rate, as well as the positive predictive value and the false positive rate as well, of the 3 evaluated commercial classifier systems. And so all of the classifiers have the highest error rates when it comes to darker skinned females, right, ranging from a 20% error rate for one commercial classifier system up to 34.7% error rate, okay? And so what that means is that 34.7% of the time, that facial recognition system is wrongly identifying who that person is. And we can see that that is based on the shade of a person's skin, right? If a person is lighter skinned, they get correctly identified more often. And we'll get into like the impacts of what that has on various communities. But just a couple of summaries as well. All classifiers perform better on male faces in this study specifically. All classifiers perform better on male faces than female faces. All of the classifiers performed better on lighter skinned faces than darker skinned faces. And then all of the classifiers also performed worse on darker skinned female faces as well, right? So these 3 very well-known commercial classifier systems were already being used in our larger society to identify people's faces, right? And so this becomes an issue specifically when you're using that information to identify someone who has potentially committed a crime, right? We can see the impacts of what that looks like. So, trigger warning again. Picture you are getting your kids ready for school, right? You're having a wonderful day, getting your kids ready for school, and a couple officers show up at your door and tell you that you are under arrest for robbery and carjacking. What are you talking about, right? What? I'm giving a talk, right? Like this is not something that happens. So you might say, okay, you're obviously looking for the wrong person. Like I'm not that person. You've got the wrong person. But the facial recognition software said that you are that person, right? So you've all seen this common anomaly, I guess, where one person commits a crime and then they approach someone else and say, well, you fit the description. Fit the description? Okay, what are you talking about, right? This is the same kind of concept. And it's given more legitimacy because AI, as we think, right, can't do anything wrong, right? But the research, as we just saw, the research shows that it very much can. So for some of us, this is actually not a foreign scene that happens. This is exactly what happened to Portia Woodruff. Has anyone heard of Portia? No, that's perfectly fine, right? So Portia Woodruff, she was 8 months pregnant, right? And she was arrested after false facial recognition match, right? So this happened just like the story. She was the first woman to be known to be wrongly accused as a result of facial recognition technology. And this happened, I believe, a couple years ago. I forgot the exact year. But it doesn't stop, right? It doesn't stop at facial recognition. There are so many other examples as well, right? So we have another one, right? So I'm gonna go over here so I can read them all. So 8 months pregnant, that was Portia. Let's keep going. This does not stop yet again. Another arrest and jail time due to bad facial recognition batch. A Jersey man was accused of shoplifting and trying to hit an officer with a car. And he's the third known Black man to be wrongfully arrested and based on facial recognition. This keeps happening. Wrongfully accused by an algorithm in what may first be known as the case of its time, a faulty facial recognition match led to a Michigan man's arrest for a crime that he did not commit. These are all New York Times articles. They keep going, right? They do not stop. This happens all the time, right? Thousands of dollars for something that he did not do, for example, right? It does not stop at facial recognition technology. But yet, like I said, again, what is biometric data used for? Biometric data is often used for fun, and also, when taken too lightheartedly, it can have lasting impacts on various communities if we ignore how it can be used against us. So as a room full of cloud practitioners as well, a lot of us might be asking, okay, so what can I do? Right? What can I do about this? I didn't develop that tech, so what can I actually do about this? So several of us, we might even in this room be working for a brand name cloud provider, right? That's leading the charge in hosting, synthesizing, and possibly selling data, or the systems that are built off of that data. And even if you might not work at a well-known cloud provider, it's our job to understand how we can have a role in shaping the very technologies that guide us every day. So a couple key takeaways that I want you all to look into and familiarize yourself with as well. So first of all is thinking about policies like the GDPR, the General Data Protection Regulation. Now this regulation is very, very long, quote unquote. It has 99 specific articles, right? The full text of the GDPR is massive, but it has 7 key principles around data regulation and use. And I think it's important for us, if you haven't heard of this regulation, please do familiarize yourself with it and bring it to your larger team as well, right? So the GDPR is one of the key places where you can learn about and start implementing change within your community and within your job. Also, I want you all to look into the IEE's ethically aligned design principles as well, right? So this is yet another guiding piece of policy that allows you to understand how can we impact artificial intelligence as we're building it and build it ethically and have a say in that. And then lastly, I want you all to think about California's Consumer Privacy Act, the CCPA, as well. So this landmark law, for those who don't know, it secures new privacy rights for California consumers, including 1, the right to know about your personal information, about what personal information a business collects about you, right? Number 2, the right to delete said information from those systems. Number 3, the right to opt out of said system. And then 4, the right to non-discrimination when exercising your rights. So lastly, I want you to leave with always stay critical, right? Always stay critical about the systems that you are using, implementing, and promoting to others, and understanding the ways that it can positively and negatively impact other folks. So a couple last resources I want you all I want to leave you all with. So this is specifically for learning more about artificial intelligence, ethical artificial intelligence as well. This is called Graph Academy. This is Neo4j's complete platform it's all free as well. It's a learning platform that'll introduce you to these concepts of unstructured data, building knowledge graphs with LLMs, all the technical expertise that you're looking for. You can even build a chatbot with Python, and we have one for JavaScript. But these are different resources to get that hands-on training in order to learn more about these concepts that I'm talking about today. And then lastly, we have a giveaway for a drone. So we have the DJI Mini SE or the Neo drone that we're doing, and we only do in-person meetups as well. So if you would like to enter our giveaway, please feel free to snap that. And I also have a slide as well in person that you can snap from it. But lastly, I just wanted to say thank you all. Thank you all so much for coming to this talk and for joining me to talk about data regulation. Thanks, everyone. Appreciate y'all.